in the concrete volume. You know it very well because without aggregate concrete cannot be prepared. Why we are giving much importance for aggregates? Because when you mix aggregates with the cement, water, etc., what happens? The concrete gains strength. But the concrete gains strength. And the concrete, of course, get durability. And also concrete get workability. Concrete also get, very good finish. When aggregate is mixed, whatever the ratio, whatever the combination, whether it is 20 mm aggregate and 5 aggregate, say 4.75 mm, then it is that, and cement, water, or if you add some artificial. If you mix everything, you will get the concrete. And we have so many varieties in concrete. We say M5, M10, M50, M20, M25, M30, M40, M50, M80, M100. Various types of grades are available depending upon the purpose. For example, for the dam, construction of the dam, we have to go for a special grade concrete. If for a house slab you want to place concrete, M20 is enough, or M25 is okay. For example, for columns and slabs. Otherwise, for foundation, you have to go for M5 or M10 grade concrete. That means for each and every concrete, there is a mixed design. So based on the mixed design, we have to proportionately mix up the coarse aggregate, fine aggregate, cement, and there is water, of course, WC, water cement ratio. So that the concrete definitely gives us strength, durability, workability, and good finish of that concern. Structure, whatever the structure, whether it is a building, an auditorium, a multi-story building, or a cement road, whatever it may be. So you will get all these properties. So the correct uses of aggregates depends. Correct aggregates. That means whatever the aggregate is coming from the quarry, will you use straight away? No. You have to study. The correct aggregates means depends on strength. That means aggregate strength. See, for example, cement rock, silk shale. If you apply little pressure, it breaks into pieces. Will you get strength? No. That's why you have to avoid shale. You have to avoid some of the rocks which are schist. For example, metamorphic rock, schist. It is a soft rock. Applying little pressure means it breaks into pieces. Similarly, metamorphic rock, slate. Just if you drop, it breaks into small pieces. That means to get the strength means you have to choose a correct rock, that is igneous rock or sedimentary or metamorphic rock, which should have very good strength. So that's why to get the correct uses of aggregate, the aggregate depends on strength. I told you strength, what is the meaning of strength. Then shape, aggregate shape, it should not be round, it should be always angular. Do you know the difference between round and angular? This is round, this is oval, this is angular. You should remember that always for making concrete you have to go for angular shape, aggregates, not round or oval or circular or whatever. So that is also very important. To get the correct strength for concrete. And durability, of course. Whatever the aggregate you choose, we should give some period. It must retain for 50 years or 40 years, not for just 1 day or 2 days. So aggregates, correct uses of aggregate depends on strength, shape, dimensions, etc. So where we use the aggregates? Aggregates are used in making concrete. That is one. railway ballast, where we use aggregate. What is the meaning of railway ballast? Did you observe a track which is lying on 40 mm aggregates, not 20 mm or 12 mm, 40 mm or above 40 mm. So over the 40 mm aggregate, the track is laid down. Why? Why aggregate is required under the track? Yeah, because it gives a lot of vibrations and sound while moving the locomotive. So those shocks, vibrations are received the aggregates. That is the reason. Everywhere, wherever you see railway track means which is laid down over aggregates. That is called, that aggregate, whatever you lay down, whether 40 mm or more than 40 mm, that is called as railway ballast. And then roads, especially roads means CC roads, cement concrete roads, you require aggregate, otherwise you cannot. Even PT roads, bitumen roads, you require 12 mm or 20 mm aggregate where bitumen is mixed, asphalt is mixed, and accordingly it is laid down. And not only these things, and even dams, reservoirs, tunnels, overhead dams, etc. That means aggregates use is multi-purpose. Not only I have mentioned only a few, but we can use the aggregates at any places. Okay, fine. Aggregates usually we can divide it into two types. One is fine aggregate, simply. The other one is coarse aggregate. Somebody says intermediate aggregates, that means mixing of both two are called as mixing aggregates. But usually aggregates are divided into fine and coarse aggregates. Now let us go to the tests. Tests on aggregates. This is the topic. Now whatever I have explained is the introduction part. And you know very well that aggregates comes from the rocks. Rocks are, removed from the quarries by digging with the help of tools. Using crowbars, spades, chisels, we can remove the aggregates from the stones which are available in the hills or mountains. Sometimes you require drilling and blasting. Then you will get the aggregates of various sizes. If you do the drilling and blasting, you will get this much big borders, this much borders, this much borders, this much borders, even small pieces also. See, there is a chart here. There are different sizes. In the same fashion, after drilling and blasting, you will get a lot of various sizes of aggregates. And accordingly, conveyor belts, divide all the aggregates into 40 mm, 20 mm, 12 mm, 10 mm, 8 mm, 6 mm, 4.75 mm. That is called dust. If you see a crusher, see very nearer to Pratap Singaram, then followed by next Gaurel. So, if you cross Gaureli immediately, right side there is a crusher. So you have to see what is there in the crusher, how the lumps are coming, and what is the crushing machine. That is called a jaw crusher. I said there are two arms. One is fixed and the other one is moving like this. So this is one arm, this is another arm. That means from the conveyor belt, the big borders fall into the jaw crusher. Then this arm moves, this is fixed. So because of the friction or pressure or load, whatever it may be, that rock breaks into pieces of various sizes. That is the initial step to get the aggregate. Then after sieving, yes, we get different sizes of aggregates. Now let us see what are the important tests which are to be carried out for aggregates. Tomorrow in the field, of course, aggregate comes by a truck, say some 10 tons or 15 tons or 20 tons, depending upon the capacity and your requirement. Aggregate comes. Will you accept to straight away without testing? You must do the test. That's why quality control engineer presence is mandatory. Quality control lab is mandatory in the site. So you are the in charge and you are the head of the particular site. Then you have to collect the data. Really the aggregate is good quality, serves our purpose or not. Then in such a case, what are the tests to be conducted to know the good quality of aggregate? So, tests on aggregates. This is the question comes in the mid-examination or semester examination. No doubt, definitely this question comes in for your mid-examination or semester examination. I said only 3 questions. That means this is one of the 3 questions. That means you must study. So, testing is very important to know the quality of aggregates. For that, there are many tests available. What are those tests? Sieve analysis, specific gravity test, then water absorption test, then aggregate crushing value, test, then abrasion test, flakiness, elongation index, and soundness test. Still there are. So you must have knowledge of these tests, especially for aggregates. That's why it is very important to gain, to improve your knowledge, not for the exam point of view. Because tomorrow definitely you will be recruited as a site engineer. Then you must know all these definitions and what is what. For example, sieve analysis, what is the meaning of it? You should know, otherwise you cannot understand the sieve analysis report. So now, let us focus on only a few. As per IS course, okay, let us see one test sieve analysis. Sieves. I said in the beginning, the aggregates are classified into 2 types. One is coarse aggregate, the other one is fine aggregates. As for IS 383, as for IS, that means IS stands for Indian Standard. Very good. As for IS 383 and IS 2386, this is the code book. And as for this, the sieves for coarse aggregates. Coarse aggregates. 80 mm, 40 mm, 20 mm, 10 mm, 4.75 mm. These sieves are required for coarse aggregate. I mean, when you pass the material, dry material, always the aggregate must be in dry position. That means it should be dry without any water, without any moisture. So you have to keep the sieves in the same order: 80 mm top, 40 mm bottom, and 20 mm below that, 10 mm below, and finally bottom 4.7. So in sieve analysis, what we have to do? We have to pour the sample on the top of the sieve. Say for example 700 grams I have taken. 700 grams of what? Aggregate. That means coarse aggregate I have taken from the quarry after crushing. Different sizes comes. Even that includes some powder. It includes some plants, debris, waste material, plastic, otherwise some clay. Because it never 100% aggregate. You will get other unwanted things also. So that 700 grams of aggregate, for example, it should be dry in form. Moisture, yes. That means we have to see that it should be free from moisture. And put it on 80 mm sieve. You keep all the sieves in a systematically order. There is a sieve analysis machine, and it requires electricity. So that in the field, suppose if electricity is not there, you can do manually. Otherwise, in the laboratory, you can keep all the sieves in such a order so that if you switch on, because of the vibration, what happens? The 700 grams slowly comes down and falls to till the last sieve. And take it. Porcelain aggregates on the 8 mm above, and less than that below that, and still less than size below that, and finally whatever it may be the powder, suppose if it is present, that passes through the 4.75 mm. That's why sieve analysis is a laboratory test as well as field test. You can do the test in the laboratory, you can do the test even in the field, I mean site also. In the site means if you have no machine, you can do manually the sieving. If you have a power supply and machine in the field, you can do the sieve analysis test. So that's why sieve analysis can be done in two ways once again, dry test and wet test. Dry test means it should be free from moisture. Wet sieve analysis means, yes, if water is poured, so if you pour water, what happens? Or if you sprinkle water, or if you forcibly apply the water, what happens? The unwanted material, whatever it may be, that goes out. Suppose it clay is seen in between clays, that's a common. So because of water pressure, what happens? The clay goes out. Suppose there is a calcium, suppose there is a root or leaf, dry leaves, everything goes away. Then once again, that is to be dried. Always remember, sieve analysis is carried only with the dry material. But two types are there, dry and wet. Dry means simply you can do the process. In case of wet, what happens if clay is present in the aggregate, that is washed away because of water. That means wet sieve analysis excellent in place of, instead of dry analysis. And coming to sieves for fine grain. That means for this we can go for 4.75 mm, 2.36 mm, 1.18 mm, 0.600 mm, 0.300 mm, 0.150 mm. These are different sieves. These are not for coarse, these are only for fine. 4.75 top, 2.36 still 0.150 mm. So these are the sieves. Now analysis, how to do the analysis, that's very, very important. Because the name itself speaks sieve analysis. Then now how we conduct the analysis test. So till now we know various sizes of sieves, and whether to carry the dry test or wet test for aggregates in the field or laboratory, we understood. So I recommended always wet sieve analysis test. Now calculation. Percent is retained. So we have to calculate. This is an analysis. Cumulative percentage retained. Then percentage passing. These are important tests for sieve analysis. Now let us see. For example, we have taken 700 grams. Okay, 700 grams of we have taken post aggregates. That means we have to pass with the different 80, 60, 70, 50, whatever it may be, 3, 4.75. We have to some quantity of aggregate is retained. So what is that? 500